All right, guys, continuing on with ionic. So we talked about simple ionic. Now we are going to go to complex ionic. I don't know that that's its actual name. It's just what I call it. It just means it has a polyatomic ion in it. And these can have, I just butchered that spelling. Let's try that again. Atomic. There we go. Polyatomic ions. These can still have general, simple metals such as S and Ps, and it can also have transition metals in them. So we're going to treat everything the same way. All we're doing is adding in this idea of how do we deal with polyatomic ions. So for example, let's say I have something like this, CaCO3. First off, I'm going to recognize that I have a polyatomic ion because I'm going to have 3 or more capital letters in the name. Or in the symbol. So like I've got this C, and this O that are all capitalized. So that means there's a polyatomic ion. I'm going to go to my polyatomic ion list on the back of my periodic table. And I'm going to put carbonate, CO3, in parentheses because that is my polyatomic ion. When we name these, we're going to name the metals exactly like we always have. So calcium is not a transition metal. I do not need Roman numerals, so I'm just going to name him. And carbonate, CO3, is carbonate. So with polyatomic ions, we're just going to name them exactly off the list. Again, we don't need to say anything about the numbers. That number actually belongs to carbonate. Carbonate is CO3, -2 anyways. We're going to put them in parentheses just so we can keep track of them. So that 3 comes with carbonate. Carbonate is 1 carbon, 3 oxygens, has a -2 charge. Calcium is +2. So we only need 1 calcium with 1 carbonate. So that's why we have no exponents here or here. Okay, let's look at another one. Let's say we have, we're going to do aluminum and this guy. Okay, so again, in terms of naming, we identify that it has a polyatomic ion because it's got 3 capital letters. Also, anytime you see parentheses like this, we know it's going to have polyatomic ions on this level of chemistry. With that, Al is aluminum. He's not a transition metal, so we just name him. And SO4 is a polyatomic ion, and his name is sulfate. So we're just going to name this guy aluminum sulfate. Again, we don't need to say anything about the 2 or 3. They're understoods because aluminum is +3. Sulfate, SO4, is -2. So I need 2 +3s to get to +6, and I need 3 -2s to get to -6 so that I have a 0 charge. Because remember, that's still what we're going to when it comes to our compounds. Okay. All right, let's look at one with a transition metal. Let's say I have this guy. And we'll do this, FeClO2. So again, I'm just going to name them just like I have been, but this is iron, which means I need a Roman numeral. Well, how do I find the Roman numeral? 2 different ways. We can do the uncross and undrop, or we can do the charge analysis. I'll do them next to each other so we can kind of see how this works with polyatomic ions. Okay, first one, uncross and undrop. So I'm going to bring up. Remember, I'm bringing up the numbers and making them correspond to the charges because these would have been the numbers I multiplied by, or cross-multiplied. So again, I always double check. I go to the back of my polyatomic ion list. ClO2 is chlorite. Is he supposed to have a -1 charge? Yes. So if he's right, he's automatically right too. So I'm going to name him iron. 3, again, this is chlorite. I just name it. And again, none of these should be capitalized. I just capitalize everything. And then over here, if I was doing charge analysis, same way. I go to the back of my polyatomic ion list and I see that chlorite, ClO2, is -1. I have 3 of them, so this is -3, which means iron must be +3 to get to 0. So I'm still going to name it exactly the same way. Iron 3, chlorite. I would say the hardest thing when we're dealing with our transition metals and polyatomic ions is when there's simplification. So let's look at, let's say this. We'll do 2. All right, so we're going to work through both of these. I'm going to do the uncross and unswap method, but we can do the charge analysis method too if we need more help before, after school, during class time, etc. So again, I'm going to recognize that there's a polyatomic ion because I've got 3 capital letters. So if I put these guys in parentheses, PO4 is my polyatomic ion. I notice that there's ones down here. I'm kind of circling that empty space because that would be ones, or that represents ones. So I'm going to bring up these ones. And again, vanadium is a metal, so he's +1. And I always double check. Is phosphate supposed to be a -1? No, he's not. He's supposed to actually be a -3. So what I'm going to do is unsimplify, because if it's a -1, it means it's simplified. If it's not what it's supposed to be, it's simplified. And multiply by 3. So I get vanadium +3, and PO4 -3, and I'm going to name this guy vanadium 3 phosphate. Okay, I'll go ahead and do the charge analysis. Again, I'm going to put the polyatomic ion in parentheses. It's not supposed to be here, but you totally can for my class anyways. Phosphate's -3. I have one of them, because again, remember, there's nothing here, so there's only one. So I have -3. Vanadium must be +3 to get to 0. So again, I'm going to name him vanadium 3 phosphate. Okay, let's jump over here and do the same thing with this guy. Uncross, undrop, Cr +2, SO3 -1. I go on my polyatomic ion list and I look for sulfide and I go, oh, sulfide's not supposed to be -1. He's supposed to be -2. So I'm going to multiply both of these by 2. And I get chromium +4, sulfite SO3 -2. And I'm going to name this guy chromium 4 sulfite. Okay. All right, and again, if I wanted to do this in the charge analysis method, sulfite's -2. I have 2 of them, so that gives me -4. Chromium must be +4 to give me 0, and I only have 1 chromium. So chromium 4 sulfite still. Okay, and there should be space there. Let's look at, I think that's pretty good. All right, so that's basically our process of dealing with more complex ionic compounds with polyatomic ions, essentially. Okay, so with that, I am going to go ahead and pause, and in the next video that I'm going to make one where we've got a whole slew of compounds, because we basically have gone over ionic in this video and the one before it. We've gone over covalent, it's in a different video. We've gone over acid, it's in a different video. So now we're going to do a mix of all different types of compounds, work on identifying what types they are and naming them properly.